Okay, so what we're going to be looking at here is the 2019 number 1 example. It's an accumulation problem. You do have a calculator. So let's just go ahead and jump right into this problem and how we do it, okay? So we look at the problem. It says fish enter a lake at a rate modeled by the function e. So this is a rate at which they are entering. And then fish leave the lake at a rate modeled by L, and this is the rate at which they are leaving. It says both E of t and L of t are measured in fish per hour. Now, luckily for us, I think anyway, because we're looking at two different rates in this problem, it actually comes out to be, it comes out pretty quick, and most of these are pretty painless, to be honest. So let's take a look at all the questions. The first one just wants to know how many fish there are that enter the lake over the 5-hour period from midnight to 5 o'clock. Well, that's just going to, because we're only talking about entering the lake, we're going to do the integral from 0 to 5 of that E of t. So we just plug that in to our calculator and make sure you're in radian mode. That's about the only mistake I could really see you making here. And when you do that, you get 153.457. So if you put 153 or 154 or 153.457, any of those answers would suffice on letter A. On letter B, it wants to know what is the average amount of fish that leave the lake over the 5-hour period. Well, in order to find that, we do the integral from 0 to 5 of L of t. That will tell us how many fish have left the lake. Then we're going to have to divide that by 5 minus 0. When we do that in this problem, the number we get is 6.059. So that's the average number of fish that leave the lake per hour. Okay, there's no units or anything. That one you do want to leave as a decimal, so we don't want a whole number answer on letter B. Letter C wants to know when is the number of fish in the lake the greatest. So it doesn't really tell us how many fish are in the lake, but it doesn't really matter because we can find out how many fish are going to be in the lake by doing the integral from 0 to whatever time we're talking about of E of t minus L of t. In other words, we're finding out how many fish come into the lake and how many fish leave the lake. So what we have to do in order to find out all of our candidates is we look at our endpoints and then we graph it and see where these two graphs, E of t and L of t, cross each other. It just so happens that that is at 6.204. So these are all of my possibilities for what my integral, or for what the times that I'd have a max or a min. So if I find out the number of fish using this formula for all of these, at time equals 0, I get 0. I plug in 6.204, and when I do that, I get 135.015 at time equals 6.204. And at time equals 8, you get 80.920 is how many fish you have. So the time at which we have the greatest number of fish in the lake is at time equals 6.204. As long as you have your table here that takes all of your candidates into consideration, and we see that this number is the biggest, that's all the work that you have to show on this problem. Lastly, and this is kind of tricky, wants to know, is the rate of change in the number of fish of the lake increasing or decreasing? Now, it wants to know if this rate is increasing or decreasing. So what I have to do is I have to find E prime of t and L prime of t, and then I plug 5 into them. A good way to do this is I say E prime of 5, L prime of 5, and then I subtract one minus the other. When I do that in this case, I get a negative number. In fact, I get negative 10.723. What that means is at this instance, the rate at which the number of fish in the lake is increasing or decreasing is changing by this amount. It's a negative number, so we would say that this is decreasing because that value that we get is less than 0. The tricky part here is knowing that it's talking about the rate of change increasing or decreasing, so I can't say whether or not the fish in the lake are increasing or decreasing, it's that the rate is doing that. That's why we had to take the derivative, because the derivative tells us whether something is increasing or decreasing. Overall, I thought this was a pretty straightforward problem. It's a good one to kind of get a feel for accumulation, and hopefully all of that made sense.